talk about agents and agentic class. This is it. This is what's happening with AI right now. I did it with AI, of course. So the idea was a little bit about security, observability, and I said, fuck it, I'm not going to do that. I'm going to show you how to build an agent or not. Because this is where we are. I've been around a lot because Pedrazas is happening, DevOps is a really now I'm an AI engineer in a small company called Autonomy. And we do a lot of training, helping people to build and understand how to use it. I also make changes. Someone was asking me changes, I make them. Yes. Why not? So, okay, what does AI provide? What are the things that AI brings to the table? You should have put a little bit of whiskey on the stand because they are very, very little.
Do you want to drink that? To the water?
I'm not going to speak louder, but yeah.
Do you want me to translate for you? You say it to me and I'll shout out.
So these are the two things that AI brings, acceleration and augmentation.
You want the second one?
We told that before, it doesn't work. Okay, what is the thing that AI doesn't provide?
Intelligence.
Creativity.
Emotions. Good.
Creativity.
Expertise. That is something that you have that AI doesn't have. You are the ones who know. And this is the thing, right? Because in theory, with AI, you can do anything. They talk about building bioweapons and viruses and all this stuff. And still, when you try to do something, it seems that the agent is not able to. Because you are limited by a few things. Time, but your knowledge and expertise. That is, you say. This is something that you can outsource, which creates a really odd situation in the market because now we have all these CEOs thinking that you can do anything with AI, which is true, as long as you have the expertise. And what do? Start finding people out there? Because that's exactly like, so if you haven't seen this video, it's funny, it's good. Right? For platforming, we have a very particular set of skills. And we have spent a lot of time trying to convince and explain developers how to do certain things. And the CEO doesn't know that he needs to do that. Everybody needs to do it. Right? So then what happened with all these? Like in 2021, GitHub released Copilots, and which was very fast because it was more Cursor. The thing with Cursor was this multi-edit was something very interesting that GitHub Copilot was not doing, which is when you have to do a change, this change is just not, this line is all over the place, and Cursor understood that very well. And then, of course, Claude Code, and now everybody is loving the terminal again. We love terminals.
Just the apps.
And then this thing happens. Anyone who's using OpenClaw? Good. I'm using OpenClaw. This is what happens, right? Like this was the madness of OpenClaw. That's it, but no, that's it. You see? It's not exactly the hockey stick that was going to go to the moon and beyond. So yeah, OpenClaw is, for those who don't know, it's an agent that you can run and you can run Telegram and WhatsApp and these things. There's another agent called Pilot.dev, and the thing is NanoClaw. OpenClaw is using Pilot.dev behind the scenes. So the handle that is using OpenClaw is Pi. Of course, we have to have something smaller and safer called NanoClaw. And how small is it? So OpenClaw, 3,600 files, almost 500,000 lines of code. using Docker Sandbox, which brings us to this security disagreement that he was talking. I'm going to like a lot of people talk about injection or prompt injection, but in reality, the majority of organizations, prompt injection is not the problem. The main problem is data leakage.
Yeah.
And credential management. It's an absolute shit show. But there's something there with all these agents that we know very well, which is the non-deterministic behavior. It's not true, like in Kubernetes we are very used to this eventual consistent world, and if you have been managing Kubernetes, you will know that people do not like this self-healing, self-recovery. I want to deploy and you have to say yes or no. Which brings me to this wonderful table of deterministic versus non-deterministic, where in deterministic what you have true or false, and in the non-deterministic you have true 90% of the times, or false 87%. And can anyone tell me what this means? Now, I use Code. I use Claude Code. I use Code, so I use Code. And I was testing, let me show you this. I have a little home lab in my house. I have a lot of things running here, and they're running my Proxmox, and I have these kind of things. I make games as well. If you want to play Sudoku, you go to my Sudoku and you can play. Anyway. True 90% of the time. What does it mean? You run it 10 times, one of them, it tells you this true, it's not. How about is this? Sometimes it's okay, sometimes it's actually my cohort was updating my home lab with Ansible, and I don't know why decided to wipe my database. This happened. And then I went like, what has happened here? I was a database, and I said, you're absolutely right. I need your database. I have a backup, so everything is fine. But it gave me the things like, now I have to teach my agent to understand that there are things that if you do it, you're going to break it and then you have to fix it. Now my agent can do database restore. Life is very sad. So what is the difference between a false positive and a false negative? Right? Like a false negative is really bad because it means that, for example, with the viruses, it's like someone who has COVID, the test says that you're okay, comes to the party and he doesn't work. False positive, well, you don't have COVID and all of a sudden I'm telling you that you have it. You're grounded, children hate me, but this is different, right? So, yeah, percentages, living the life. So anyway, there's a whole bunch of new tools that we have created because we need isolation locally. And most of them use microreaders, Fargate, and I'll put the QR codes for the slides. The slides are in the GitHub, so you can get all the things. You don't have to harvest them. But there's a whole bunch, and all of them basically work in the same manner, right? Like they try to give you network isolation and limit the access to the file system, and which tools you can use. Not you, your agent. Right? What we don't have yet is access to credentials. Access to credentials is a problem that we haven't solved yet for agents. And the truth is that not all the agents are the same. These are the personal AI agents. These are different. These are different kind of bits because they are operating on behalf of you. They pretend to be you. So permissions usually are about what you can do and what you cannot do, not about what your robot can do or your robot cannot do. This is personal agents. Usually, when we want to create agents, we talk about deployment agent and the PR, review agent, and all these things. These are things based on use cases, and these are more like an agentic workflow. Kind of a workflow example, we will talk about building an agent that is going to instrument all your applications. So if you think about the problem that we try to solve is about, give me a GitHub repo, I will analyze it, and I will add telemetry, Prometheus metrics, and blah, blah, blah. Right. In platform, we tried this many, many times, and different success. And it's because, well, right, so this is a workflow, and the key is understand that you have a use case. So be obligated. You want to deal with your mess in code or whatever, right? If you really think about what an agent needs, it's very basic. It needs tools, it needs system problems. This is what you need to do when you build an agent. You have access to file system resources and MCPs and CLI and all that. But in reality, there's these two things, system problem and tools. So let's talk about the adoption, right? Because everybody who works in a company like, oh, we need to build something with AI. Okay, what are we building? Don't know, but we need to do it. Okay. And then you try to build something and it's like, this is a piece of shit. So what is the problem that we have here? When I talk about OpenClaw and work and this kind of automation, personal automation, people ask me about, can you give me these 3 or 4 tasks that I can automate? And it's very hard for me because the way they work and the way that you work is different. I was talking with someone earlier about home automation. The way I have automated copy, the way I have automated my house, and the way that you will automate your house is very different. So I can tell you things that doesn't make sense for you. Because what really people are saying is like, this tool is really cool. Really like it. I don't know what to do with this. Right? Because it's not about what the tool does. Right? It's not about doing. It's about not doing. How many of you have a washing machine? Jesus Christ. There's always someone. I used to say dishwasher, but then it's not a washing machine. Okay, for those who have a washing machine, what happens when the washing machine is broken?
You call the plumber.
I'll buy a new one.
Very fast. I have to keep very fast because washing clothes, yeah, but you do it very differently. You have a washing machine, you don't. You have an automation that helps you a lot. So this is the key. It's about changing how we do things, particularly what you don't want to do. Right? Remember, change is very hard. We have a certain capacity to absorb change, or to learn. Right? So you have to give enough time to digest. This is very important. If you don't do it, you will just lose grip of what's going on. Which is probably what you're feeling with AI. It changes so fast, so much. Another thing, how do we validate and verify? Coming back to the expertise from Eric, how do we know that we're doing the right thing? Right? All these AI's options that we talk about, how do we know that we're doing the correct and valid thing? And by this I mean do things the way that you expect, right? Like following policies in your enterprise. And that's what it's supposed to do. Because you follow all the policies and my robot makes dinner using something that's going to be poisonous for me, dinner might be great, but it's not doing what it's supposed to do. Right? So I was spending a lot of time on that. Okay, what does it mean? So I created this tool. It's called I'm very bad with names, as you can see. Okay, there is a tool. Here it is. I'll show you what can I show you? Is it big enough? Yes, I can do something like this. So it's going to run a bunch of checks. It runs your test, it runs your test coverage, it checks if you have password or secrets, it goes and tries to do a lot of things, 56. I always choose a broad example, but anyway. But this is trying to understand, is like, you give me something, I'm going to try to understand if what you have done, whatever it is done the way that you expect. When we talk about this application, this code is good, what are we talking about? How would you define good code?
It's understandable when it does process tests that you want to have.
Yes. So there's a check here that checks for the complexity of the code that has been written. Right? There's a whole bunch of things, and it's super slow because life hates me. But I have a scripture somewhere. Here. Which is not great. Be patient. I'm not very patient, as you can see. I'll show you another thing. Like, I was fed up I run auto fields, and then I said, I want to have this nice URL. So I create this tool. It's in GitHub as well. And what it does is you create the domain, and now this is the URL that I'm using, slides. But if you run any container, it will create these kind of things for you. It's nice. Ah, excellent. So it's done. Right? And it says code duplication. You have code duplication. You have pipelines. You have endpoint. You have secret detections. Like these checks are deterministic. This is not deterministic. You can do the same thing going to Claude and say, can you check if the test or there are secrets or whatever. Right? What is the difference? I want something that I can do and it says true, and then you can do it and it says true as well. Right? It has to be consistent. If you use Codex and I use Claude, and we ask the same question, we might have different answers. This is not good in some scenarios. Oh shit, I don't know what things. Oh yeah, the dependency phrasing is always interesting. Like it is because what we were talking earlier about the dependencies and all these questions. Okay, let's go back. This is something new. I'll show you because I have all the links here at the end. This is the tool that I'm using to do this because I know that you will ask me, so this is it. And it has a lot of things very nice. Okay, let's go back to okay, we are DevOps. Let's talk about the language. The goal is to have all the application instrumented and properly configured. Yeah, nice goal. Anyone does OKRs here? That's it. What's the problem? The developers don't have the expertise required to do it. We don't have the bandwidth. What is the solution? Yeah. Well, whoever has the expertise should do it. What is the problem with this? We don't have enough people to do it. So now, with agents, we do. Okay. So what do we want to do? You define a bunch of hypotheses. This is like, I was a Docker doing Docker Labs, and I created this kind of little framework to help you to build things very fast. Right? You create an hypothesis, and then you tell me how you're going to validate your hypothesis. It's like saying that developers don't want to deal with platform consensus is not good enough. You have to tell me how you're going to validate it. Right? Tell me how you're going to validate it, and then we do it. Right? So, this is how you're going to build your agent. You start for something that is called a skill, and a skill is the love child between a macro and an SOP. That's it. You will never hear this definition anywhere, but this is exactly what happens. You have this YAML file, this markdown file. Sorry. Too many years, we couldn't. You have this markdown file that allows you to define how the agent has to do it and which tools have to use. Right? Excellent. So you define the scale. You define the different steps. Check out the repo. Like, make sure that we validate that it has this or not. Right? Like dependencies, we can check if they're using the libraries or not. Super easy to do. Right? One thing that you will see is that you can delegate on Claude or whoever and doing it, or you can build your CLIs. The writing code is very cheap to do it, because what you're doing is going from a non-deterministic to a deterministic scenario. Right? When I do this, our platform is this way. When I do this, what you are doing is doing a deterministic chain. That's it. It doesn't depend on the model, it doesn't depend on anything. You have given me this input and I'll give you this output. Right? Now, make sure you define these two things. These are the bit that usually people don't do. Define the success criteria when the agent has done a good job. If you have a job, then you can say deploy. It's nothing but with agent. Or what to do when it fails.
I think the sunset's happened.
Oh, it's because okay, like what happens when you want to stop and when you want to define it. If this problem happens, don't carry on, because agents will carry on, as you have seen with Claude. Oh, I cannot do this. Oh, you don't like me to use Git. Don't worry, I will write this shell script and I will use Git because. And the other thing is about understanding the capacity you have to digest, you and your users. That's like, so for example, the first thing you do the agent, just make them to create a report instead of, changing someone else's code. Then, once you're comfortable with what the report is saying, like, okay, let's try to do what the platform will review and carry on. Until you are comfortable, and then you can say, well, I think this is completely automatable. These are the things that usually don't happen. And like you go straight to, I want to do this, with a lot of non-deterministic, it makes everything very complex to very quick. So, start with the skill. Once you have the skill and the CLI, what you can do is to give these to someone using Claude Code or Python there for Copilots. And then say, like, try to do this and see how it goes, see how it's working. Right? Don't think you have to write the agent code. Agent code is not difficult, but using Py, you can use Py in RPC, and it's just like an endpoint you can hit. Put this in a container, put it in a cluster. That's it, and with the agent. What do you need? What you really need is system call. So this is the agent that I've written, and this is the system call. You don't really need much. This is how you're going to drive the, and this is the scale. And the scale basically is telling phase one, or repository listing, then instrumentation analysis, and history tracing, and blah, blah, blah. Right? It's not hard, but if you try to do too much very soon, it's going to be very difficult for you to grasp what's happening, what's not. This is a piece of code. There is more. It's 15 lines of code. This is an agent, and this is the system code. So if you come, use this code and put your system code here, you have an agent doing what you want to do. This is using Py. That is like, think about what you really want to validate. Think about what you're really testing. Right? This is the most important thing you have. That's one. Okay. Because what happens is once you have these fully automated agent, magic happens. Because all of a sudden, you remove this concern from the developers, and the platform gets out of field. Now we are free to change how things work. Because this is a platform concern, it's not the developer's concern. This is my Grafana. My agents do not like Grafana. My agents are like, I use MCP and you do that, but in reality, the way that you look at your dashboard and says, I have autonomy here, if you try to do that with an agent, it's painful. Right? This is where So Docker I was looking at this is where I realized that actually having something like this is kind of a much nicer pattern. Let me show you a different tool that I have. So I have my home lab, and I have a few machines in my home lab, and I have a whole bunch of containers in my home lab. Right? And what happens with this is that my agent calls this CLI, the CLI calls the API. The agent never says my credentials, because the CLI handles the credentials. Right? Why I'm doing this? Because I didn't want to have an agent getting. I didn't want to use Docker. I didn't want the agent to be able to use Docker. And I didn't want to use my SH keys. I didn't want to give all the information to the agent. How do I limit the data that he has access to? Give you the tools that you can access, and you can use, and then, yes, there's Docker here and there's protocols there, but you're not allowed to touch it. Right? And writing the CLI, and writing this API was, a couple of days. And now I don't have to worry about all these things. Someone was saying, like, you can do something similar because, of course, I created UI. Writing code now is free. Right? Do I do anything with this? Sometimes. Oh, shoot. My container is gone. You can come. I don't know why it's not working now. Anyway, you can, in theory, you can see the logs, but no, it isn't what's happening.
I think you've got a search query in the bottom.
Sorry?
There was some text in a search query, I think.
No.
The containers.
Oh, no, that's it. Oh, it's true, yeah.
Okay.
Yeah. So you can come to the container and I can pull on deploy and the deploy is time and I can read the logs. I don't remember why I did it, but I had the API, I had the CLI, it was very easy to build this UI on top. But the key about writing the API CLI was about this. I don't want the agent to have access to it, I don't want the agent to have access to my SHS. So in summary, you want to write an agent, define the use case, define the process, and you have to think about how to verify the data. Once you have this, you can go inside just writing the scale and you can do everything. Write the system from, and you get into the real. I gave a talk in Amsterdam, in container days. No, OpenClaw Summit. And what I was saying there is, you have to go and play with these things, and you have to try and iterate. And that was the whole key of the talk. You go and get your hands dirty and see what works and what doesn't work. Because otherwise, there's so much, there are so many moving pieces that you will get lost. And when someone says you have to build an engine, you're like, and building an agent is two things. Defining the system prompt, defining the scale, and using one of the handlers that we have there. You can write either there, you can run Claude Code in a container, just checking prompts and getting the output. It's not difficult, it's not nice. Next way of doing this, but it is. Somebody would help you to do it. Is this the right approach? Right? So, a lot of links. And these people, Stripe are doing something that is basically, they use an agent to validate what the other agent has done. Yeah. Okay. It's one of the options that you have. And this QR code goes to my GitHub repo where there's nice out with all the information there. So, and if you want to run it, you just put it in your machine and I'm not sure if it is somewhere. Yeah. Run or something.
has got one. Let's go to you straight away.
Thanks for a great talk. I'm investigating and experimenting with small language models.
Okay.
And the reason for that is that you can then attest to the provenance of all your inputs. And it's also far more efficient because a large model contains lots of stuff that you don't really need. So my question would be, if you are looking at designing your own agent system, and it's on a DIY basis, then would a small language model be useful or not? So I don't know what your experience of that. Just comment on pros and cons.
Yes.
Brilliant answer.
So the issue with small models is that they're small. Yes, so that is. And so depending what you want them to do, they will struggle. Now, if you interact with them, you will see that they will answer you, but it's not the kind of answer that you want or the quality that you expect. So for a lot of the things that we do, small models are more than enough. But why do I want to use a small model when I can use a big one?
Yeah, cost.
Yeah, but so in my home I run well 3 and something else. But then I do some of these things with videos, and there's a lot of local models you can use. If you have hardware, which I don't. If anyone has a GPU that doesn't work, I'll be happy to use it.
London DevOps GPU Beer Walk. Any other questions for Ivan? Let's see, you need more hands go up. Okay, that was brilliant. Thank you very much.
So the repo I have this directory, and this directory has the whole agent implementing this thing using Claude SDK. So you have it there as well.
It's all there at your fingertips.
It's all there. And if not, reach out. You can always ask me things. I'm very happy to talk, as you can see.
So the next one on the DevOps will be a mud fight. Looking forward to that. Right, another big round of applause for you. Thank you.